In this example, we're going to show how to graph the rational function, and then from there we'll be able to identify what the domain and range is for the function. The first step is to factor both the numerator and the denominator. And so when I look at an x squared minus 25, I recognize I can break it down as x minus 5 and x plus 5. In a similar way, as I factor the denominator, I have to ask myself what two numbers multiply to give me 16, yet add together to give me negative 8. Result, hopefully you come up with, is x minus 4, x minus 4. As I look at the numerator, I'm locating zeros. What values create a 0 in the function? And I can get that with a positive 5 and a negative 5. As I look at the denominator, I find those restricted values, and a restricted value would then create an asymptote. It doesn't exist there. You're not allowed to divide by 0. So a 4 minus 4 gives me a 0. Can't divide by 0. So I call that a DNE, and then this is much the same thing here because, again, it's x minus 4. Now you see that I have signs here. The signs come from very much our previous examples where we have to inspect by plugging in a value that's not a critical point. And so I'm going to choose something that's less than negative 5. I choose something like negative 10. When I throw a negative 10 in here, that would produce a negative, 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 negative. With 4 negatives, the end result is positive, meaning that the function would graph above the x-axis. In a similar way, I choose a number between negative 5 and 4. The obvious choice there is 0. If I plug 0 in, all the x's would drop out, and I can look directly at what's there. And so I'd have a negative, a positive, a negative, a negative. 3 negatives would result in a negative, meaning it would be beneath the x-axis. Finding a number between 4 and 5, I could try something like 4.5. At 4.5, this would be negative, positive, positive, positive. With 1 negative, the result would be negative. And so once again, this tells me I'd be beneath the x-axis. And then throw in a very positive value in, like 50 trillion. When you plug that in, it would be positive, 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 positive. End result is positive. From here, I would look at what I have. I have zeros at negative 5 and 5. That's what I've already stated. That's why I have zeros here. I would have a vertical asymptote at x equal 4. And I wrote here x does not equal 4 because I can't have 4. That's what that says. And that's why this is a DNE. Furthermore, if you look at the ratio of the leading terms, so the most powerful term on the top over the most powerful term on the bottom, I have x squared to x squared. That ratio of leading terms would be a 1-to-1 ratio. And that would imply that I have a horizontal asymptote at y equal 1 because that's the ratio of those leading terms. Now from there, I want to check the end behavior. And so what I'll do is, in my calculator, I can type in the function. Now I've already typed the function in. And so you see in my calculator I've typed in the original function. And then I can call up values. So to call up a value, which we've talked about before, I'm going to hit the variables button right here. See where it says variables, V-A-R-S. Variables button. I'm going to go over to Y variables, call up function, function 1. So on my home screen I want it to say Y1. And then what I'm going to do is plug in a negative number. Now when I put my negative number in it needs to be clearly away from this negative 5. So I'm going to go kind of extreme. I'm going to put negative 100 in there. When I put negative 100 in there, my result is 0.922. Which tells me, as I'm looking at this horizontal asymptote, that I'm going to approach 1 from the negative side. And so I'd write the limit as x approaches negative infinity, which is just a fancy way of saying, as this function gets closer and closer to negative infinity, we're going to see that the y value is going to approach 1 from the negative side. You notice how I wrote the sign after the number. In a similar way, I can find out what's going to be the positive end behavior. And so I'm going to call up that same function. This time, instead of putting negative 100 in, I'll put positive 100 in. When I put that in, I get a result of 1.0823. And that tells me that as I get larger and larger with my x values, the horizontal asymptote, I will approach 1, but I'll approach it from the positive side. See, I'm just over 1. And so it'll get closer and closer to 1 from the positive side. Now, as a quick sketch, here is my prediction. Let me put my number line here. I've got -5, I've got 4, and +5. So I try to do this somewhat to scale here. The negative and +5s were 0. So here's a 0, here's a 0, and this was an asymptote. And you would have your y-axis here, just to make that all complete. Okay? According to what I had for my number line, I'm going to keep going back and forth here. This told me I was above the x-axis, but I was approaching 1 from the underside. So if I mark a 1 on my y-axis, it tells me I have a horizontal asymptote at y = 1. I need to approach 1 from the underside. And so I have something like this. It has to come over, it's going to hit that 0. And then it has to go beneath the x-axis all the way down to -infinity because we have that asymptote. So this is going to shoot over, go all the way down like that. As I become immediately to the right of the asymptote, it tells me I'm still negative. So that means I'm going to come from down here, and then this function is going to have to come up, hit the 0, and then a phenomenon is going to happen here. I'm supposed to be approaching the 1. Now, I have a choice. I can either do a traditional approach to 1, like that, where it would look all well behaved, or because I looked at that end behavior, the end behavior was telling me I was approaching 1 from the upper side. See, we're at that 1 plus, so it meant I had to be just over 1 and then come down and approach 1. So it's going to create this thing that I call a popper. It's going to come up and then come down and approach 1. So we have that popper. Please don't lose focus of what your quest is. Your quest here, or your question, however you want to word it, is to identify all the x values and all the y values. So you want to identify the domain and the range. The domain would be pretty easy because as you look at this and you run across the x-axis, you can hit just about every x value. You know, whether you're here, you go up, or here, you go down, whatever. You could hit every x value. There's a value, there's a y value to correspond with that, except for at 4. And then we start all over again. You could have all these x values, and that would go forever. So to represent that, you could have every value except for 4. You could start by saying -infinity, parenthesis, because we can't contain -infinity, all the way up to 4. I cannot have 4, so I can't contain it. Unioned with 4 all the way to +infinity. Perhaps that's inefficient to write that way, but that is the question. They want us to write the domain using interval notation. You might be sitting there saying, well, wouldn't it be easier just to say x cannot be 4? Yes, it would be, but according to the directions, this is what we want. We want interval notation to represent all the x values we can have. Now, as we move on to the range, we look at all the y values. So I run this across the y-axis. I can hit every y value down here. So I'm going from -infinity. It comes up, it comes up, it comes up, it comes up. You say, but it'll never hit 1. I agree over here. This would be from -infinity, and I could never get to 1. But as you look at this element, I can go up. Obviously, I hit 1 here, and then I go a little over 1. And then because it's a horizontal asymptote, our end behavior says it's going to approach back towards 1. And so really what I have to do is say, I can go from -infinity, you can give me any negative y values you want all the way down to -infinity, all the way up to right here. I hit every value, I go positive, I go all the way positive right to there. Now, the big question is, where is that? What is that y value? And so I want to go back to my calculator, trying to teach you some functionality of your calculator. I turn my calculator on, and I'm going to graph this. So I hit graph. And it's graphing, it's graphing, it's graphing. Now again, when I do this by hand, I can show you all my asymptotes. Here's the x = 4 asymptote. Here's the y = 1. And you may notice This doesn't approach 1 immediately. It takes a while for it to get up to 1. So it's at 0 here, and then it's slowly going up to 1, and it'll go up to 1. As we check that on the extreme value, I had to put negative 100 in there before it started to get really close to 1, and it was approaching from the underbelly. But on this side, you see where it pops. You see how closely my sketch matches this? It really pops up there. So it pops up and it comes down. To find that maximum value, I'm going to hit second, trace, and then I have an option called maximum. That's number 4. So I'm going to go 4. And what it does is it allows me to move my cursor. My calculator may be a little bit different than yours, but it has the same functionality. And so I just keep moving the cursor over, and you see how I'm getting close to my suspected maximum value? It's asking for a left bound, so I hit enter after I move that cursor. And so it's giving me a left bound. I want to go to the right. I want to go farther than where my suspected maximum value is. I hit enter. Now for this calculator, it actually gives me markers. It says, look, here is your left bound, here's your right bound. And then for you, you probably won't have that on your calculator, but you can just hit enter after you get those 2 values. And they're arbitrary, just as long as you're beneath your suspected max and you're above, in terms of the x value, your suspected max. I hit enter. It thinks about it, and then it's going to report a maximum down here. I know it's hard to see on the video, but it says x equals 6.25, and then there's some other decimals there. I'm not interested in the x value, I'm interested in the y value. And so then it says y is equal to 2.777. With that 2.777, I know I can contain it. I'll actually have this value here. So I'm going to put a comma and say 2.778. I'll go 3 decimal places, round appropriately, and I'll put a bracket there, meaning that I can actually get to that value. And that would be the highest y value I can get to. So this thing pops up to 2.777, that's the highest value, and then it comes back down. I go no higher than that in terms of my y's. So I say for the range, it goes from negative infinity all the way up to 2.778. That's the largest value I can get, and I can report that. Again, on the calculator, the way I was able to find that was by hitting second trace, and I called up that maximum function. And the maximum function gave me that point right there.